In this example, we will eliminate the parameter t to rewrite the following parametric equations as a Cartesian equation. Note that we are specifically going to do this problem, and we are going to make sure that our answer does not involve any trigonometric functions. If you look at what we have here, we have x equals 5 plus 3 times sine of t, and y equals 6 cosine of t. The typical convention when trying to make this into a Cartesian equation is to try to isolate t and use that to plug in for the other equation. However, just to demonstrate why we're not going to do that, if I did try, I could, for example, take y equals 6 cosine of t. And I can isolate t by dividing by 6. And then taking arc cosine of both sides. That will give me t equals arc cosine of y over 6. I now have t as a function of y, and I can try to plug that into the other equation, x equals 5 plus 3 sine of t. I can plug this in for t. And what that would look like is x equals 5 plus 3 sine of arc cosine of y over 6. Now that's what we would do if we would simply isolate the variable t and then try to get a function of just x and y. Now we're not going to do that for two reasons. One, because the instructions of the problem make sure that we do not want trig functions in our final answer, so this would be bad. But the other reason, the main reason, is because if I look at this equation I have now made, I have no idea what that is creating. Or at least it's very difficult to have an understanding of what that is actually making or what that should look like on the Cartesian plane. What we have here, this original set of parametric equations, this actually creates a picture that you should be very familiar with, or hopefully very familiar with. And so we're going to do something different in order to keep that relation, to try to have an understanding when we are done of what we have created. So we are not going to do this. Instead, if you notice, for both x and y, we have sine of t and we also have a cosine of t. One thing that we can do is to try to use identities that can help us connect sine and cosine for some other value. For example, one identity that we could use from the past, the Pythagorean identity, is sine squared of t plus cosine squared of t is equal to 1. This is an equation involving sine and cosine that connect those two and does not introduce another trigonometric function of t. This is why I'm not using tangent of t equaling sine over cosine of t. So I'm not using that because it would introduce another trigonometric function of t. This only involves sine and cosine. What my goal now is to not get t by itself, but to get sine and cosine of t by themselves. As if I know what sine and cosine of t are, then I could plug them into the equations here, because sine squared of t is the same as sine of t taken to the second power, and cosine squared of t is the same as cosine of t taken to the second power. So if I can solve for sine and cosine, I can substitute them in accordingly. So that's what we will do instead. So if I take the first equation there, x equals 5 plus 3 sine of t. My goal here is just to get the trigonometric function by itself, so I only need to move the other constants. Need to move the 5 and the coefficient of 3. I could subtract 5 from both sides to get x minus 5 equals 3 sine of t. And then I can divide by 3 to get x minus 5 divided by 3 is equal to sine of t. I now know that I can plug in for sine of t, I can replace this with x minus 5 divided by 3. If we could do the same thing to get cosine by itself, then we should be done. And to get cosine by itself, I don't even need as much work. All I need to do is get rid of that 6 by dividing both sides by 6. Y divided by 6 is equal to cosine of t. Therefore, I know I can replace cosine of t with y over 6. What this will then look like then is x minus 5 divided by 3 taken to the second power plus y over 6 taken to the second power as well. And that is equal to 1. If you prefer, if you don't like this expression, which this expression is good as this is a Cartesian equation that does not involve trigonometric functions, you could also write this as x minus 5 squared divided by 3 squared is 9, plus y squared divided by 6 squared is 36. I mention this because this may be a little bit more familiar to you if you've seen equations like this in the past, as what we have created here is an ellipse. This is an ellipse that is centered at 5, 0 based on the value inside of here. And it has a major and a minor axis. It has a minor axis along the x direction, so it has a minor radius, you could also say, a minor radius of 3. And it has a major radius of 6. So it's an ellipse that is stretched further in the y direction than in the x direction. If these denominators were both the same, like if this was 36 and 36, then this would actually be a circle instead. But the different denominators tells me that this is going to be an ellipse instead. That is why we used this method instead. From this set of equations, which are a little bit more familiar most likely, we have an idea of what we have created and what we're working with. Whereas the previous equation, that was sine of arc cosine of y over 6, that is very unfamiliar. It's hard to have an idea of what that is creating. But overall, our final answer here, so we have x minus 5 over 3 squared plus y over 6 squared equals 1, which is the equation of an ellipse.